So let's go through these questions you sent. On this first one about expanding, I actually looked at the answer you wrote, and it was kind of interesting. I would have actually went back and gave you credit on that one on the exam. What you did was you expanded it like this, like so, and you recognize that right here that cancels out just to a 2. Now what you did, what was kind of interesting here, is you changed the 8 to a 2 to the power of 3, and then you moved the 3 in front. And so the computer counted that wrong because you went a little further than necessary. But like I said, if you had put that as your answer on the exam, I would have actually gone back and given you credit. But really, you could have just stopped at this point right here. Let's see the next one. Okay. Um, let's go ahead and look at this. So what we're going to do here is the square root of 5 is the same thing as, let's see, so we have 5 to the x minus 5 over 4. That's the same thing as having 5 to the power of 1/2. Then we use the 1-to-1 property, which basically states if the bases are the same, you can cross them out and then just set the exponents equal to each other. And then from here, really, it should just be some algebra. So what we would do is multiply both sides by 4 to get rid of that, get rid of our denominators. So the 4's would cancel out here. We'd be left with x minus 5 equals, and then half of 4 is 2. And then we go ahead and add 5 to both sides. And there we go. We get x equals 7. Okay. Let's see our next one here. All right. So this one says solve the following logarithmic equation. Be sure to reject any of the x values that are not within the domain. Give the exact answer, and then use the calculator to obtain the approximation. Okay, so what we want to do here is we want to isolate the natural log, and then we'll raise both sides, or we're going to insert a base of e on both sides. At least that's the way I would approach it. So the first thing you're going to want to do is subtract 5 from both sides. So then we end up with 18 natural log of x equals -2. Then we'll divide both sides by 18. So we get natural log of x equals -1/9. And then, I mean, you can convert it from log to exponential form, or a little trick that a lot of people like to do to kind of to expedite the process is kind of like the reverse of the 1-to-1 property, where we remove the base 5. What we'll do here is we're going to insert a base e on both sides like that. And so the property here is that this will cancel, and we're left with x equals e to the power of -1/9. Okay, and I see that's the answer you put. What they want you to do is go ahead and go a little bit further on this. They're going to want you to go ahead and take the reciprocal and put it as 1 over e to the 1/9. And then they're actually going to want you to convert that to radical form. So it's going to be 1 over the 9th root of e. So that would be your exact answer right there. That's your exact answer. Now, to get your estimated answer, when you put this in the calculator, since the calculator is doing the work for you, it really doesn't matter which one of these you put in the calculator. So if you want to, you can just put e to the -1/9 power, or you could type in 1 over the 9th root of e, but it's probably a little bit easier just to type this in the calculator right here. And so we get point, let's see, what does it want us to round? Uh, okay, so 2 decimal places only. So 0.89 right there. So 0.89. And by the way, as far as checking to make sure that it's within the domain, in this particular example, as long as it's positive, you're fine, because you can evaluate log and natural log only at positive numbers. So that shows us that works. Okay, let's see another one here. Okay, so this one, what we have to do here is we have logs on both sides. So what we're going to have to start by doing is condensing the left side. So that would become log of x plus 11 all over 2 equals log of 2x plus 2. And then this is a one-to-one property again. What we can do here is remove the logs and then just set those equal to each other and solve. So let's see, we got x plus 11 over 2 equals 2x plus 2. So we'll start by multiplying both sides by 2. And so that cancels out. And so we're left with x plus 11 equals, let's see, when I distribute that, it'll be 4x plus 4. And then, let's see, I'll subtract an x from both sides. So 11 equals 3x plus 4. And I'll subtract 4 from both sides. And let's see, that'll give us what? 7 equals 3x. And then we'll divide by 3 on both sides. And there we go. We can see that's the same answer they got right there. All right. So we have this other one here. It says investing. So how many years will it take for 6,000 to grow to 10,000 if it is invested at 6% compounded quarterly or compounded continuously? So we'll look at both cases. So if you're compounding, if you're not compounding continuously, basically, we're going to have A equals P times, let's see, you'll have 1 plus your rate over the number of times compounded within a year, raised to rate times time. So that's the formula that we'll use for part A. So let's see, A equals, so we're going to, or actually we already, in this case, we know what we want to invest and we know what we want it to grow to. So we know that we want our accumulated value to be 10,000 and we're going to invest 6,000 and it's going to have 1 plus, and then let's see, the rate is 6%, so 0.06. And then we're going to compound it quarterly, so it'd be 4 times a year. And then that's going to be raised to rate times time. So our rate is 0.06 times, and then our unknown, which is going to be time. Real quick, let me fix something. You're probably scratching your head. Let me fix this. I'm sorry. I started thinking of the continuously compounded for a second. That should be n times t. So the our n value should be 4. So sorry about that. I'm sure I confused you there for a moment. My apologies. So, okay, now we're ready to go ahead and solve for time. So we'll start by dividing by 6,000. Okay, and so that'll cancel out here. Let's see, all this cancels and reduces down to 5 over 3 equals 1 plus 0.06 divided by 4 raised to 4t. Then what you need to do is either take the log or natural log of both sides. It really doesn't make a difference, whichever one you want to do. I'll probably just do natural log just because it's easier to fit it in right there. And so let's see. So when I do that, what that's going to allow me to do is now I can move the 4t out in front right there. Okay, so now I'm going to have 4t times the natural log of 1 plus 0.06 divided by 4, which I can figure out what that is if I really want to, but I'll just leave it like that for now. And then equals the natural log of 5 over 3. So I switch sides just because I like to solve for my variable on the left, personal preference. And then what we're going to do is divide by 4 to cancel that out with the t. And then I'm also going to divide by natural log of 1 plus 0.06 divided by 4. So we're going to divide by all this here. Now the tricky part is going to be putting it in the calculator correctly. Okay, So you can download this calculator for free for not using this. If not, you might need to do this part in steps and just keep rounding your decimals um, to help you out here. So let's see, we're going to have natural log of 5 divided by 3, close it. Oops, 5 divided by 3, there we go. All right, so now when I divide it, I need to open up a parentheses. And the reason why is now I want to divide by 4, and I also want to divide by the natural log of 1 plus, let's get this out of the way so you can see this, 1 plus 0.06 divided by 4, close it, and then close it a second time. So a parentheses opens up automatically when I do my natural log, and so I want to have the 1 plus 0.06 divided by 4 in there. But I also put parentheses around the 4 times the natural log because I want to make sure that it's getting divided by the whole thing right here. So if I don't do that, that'll make a huge difference in my answer. So here we go. So I'm getting 8.58 when I round 2 decimal places. So 8.58 is what we're looking at right there. Okay. The second one's actually a lot easier. So for continued compounded continuously, we use A equals PE raised to RT. So I accidentally put that up there earlier, but now it is going to be RT. Okay, so we'll plug in what we know and solve for it just like we did on the other one. So we want to accumulate 10,000. We're starting with 6, and then it's going to be E raised to my rate 0.06, and then times time again. And my answer is going to be really close to this other one. It might shave off a little bit. It's not going to make that big of a difference. It's still going to be 8 years and something, so we'll see. All right, so we'll start by dividing by 6,000 again. So that cancels out. That'll reduce once again to 5 over 3 equals E raised to 0.06t. Now, like I said, this one will actually be a lot easier. So what we'll do here is I'm going to sneak in a natural log on both sides right there. And let me get myself some more room. Okay, so what we'll do here is, see, this will just cancel out here. So I'm going to be left with 0.06t equals the natural log of 5/3. And then what we'll do here is divide by 0.06, 0.06, that cancels out. T equals, and so we'll put this in the calculator again. This one's much easier to put in the calculator. So natural log of 5/3, and then we're going to divide it by 0.06. And there we go. So 8.51. So it didn't make too much of a difference, but it happened a little faster because you're compounding continuously on that one. All right, I hope those help you out.